All right, ladies and gents. If you guys are seeing this video, that means I am off getting my vaccine shot. Yeah, take it for whatever it is. I'm going to give you a lesson on how to solve two-step equations here, and then I'll give you your homework after this lesson. Without further ado, let's go over the lesson. I just want to do a little bit of a reminder of the things that we have already done first. So let's talk about the first one-step equations. So here are the one-steppers. One-steppers. That means we're just going to take one step in order to solve them. Okay. So let's take a look at a few simple ones. We have the x plus 15 is equal to, I don't know, 9. Right. So this is one step, and we use the subtraction property of equality in order to solve this. So we have to subtract 15 from both sides. Oops. And remember, there's a left side and a right side to this. Okay. So x, you left with x over here. This cancels out because positive 15 minus 15 gives you nothing. So that's 0. And then you have 9 plus negative 15, which gives you negative 6. Okay. So this is your answer, and what you just used here to solve is the subtraction property of equality. I'm just going to, abbreviate that with PO, property of equality. Okay, so that's one-step equation. Here's another one. Um, Negative 3. Well, maybe we should number this. This is 2. Negative 3 plus x is equal to, I don't know, let's say 10. Let's keep it easy. So in this case, what we're going to have to do is add 3 because we want x by itself here, right? And this is there's the left side. This is again the left side, and then we have the right side. And we want to get x by itself. So we need to get rid of the negative 3. So we want to isolate it. So we need to add 3, do the inverse operations and add 3 to both sides. This makes it go away because negative 3 plus 0 gives, negative 3 plus 3 gives us 0. So we're left with just x on the left-hand side. And on the right-hand side, we have 13. And the property we just used is here. This is the addition property of equality. Okay. Now we have another one. Change the color. 3. Um, this one, let's do negative, I don't know, 8x is equal to negative 32. Now, notice that this is unlike the other two. The other two have addition and subtraction. This one is multiplication. So we know that negative 8x means negative 8 times x. So what we have to do to get x by itself is do the inverse operation of multiplying by negative 8. And the inverse operation for that is dividing by negative 8. So what we end up with is on the left-hand side, the negative 8 divided by negative 8 cancels out to become 1, and 1 times x just gives us 1, 1 times x gives us x. And that's equal to negative 32 divided by negative 8 gives us positive 4. And what we just used here is the division property of equality. Okay, so it took us only one step to do this. Now let's take a look at another one. So I'm just kind of rapidly scrolling through the different things that we have done, just as a reminder on how you do these. So let's say we have x divided by negative 5 is equal to, say, I don't know, 25. Now, if you don't know how to solve this, you may be tempted to you may be tempted to divide by negative 5 on both sides, but that you'll be wrong. Because what this really says is x divided by -5. And we always want to do the inverse operations to undo what we've done. So on the left-hand side, what's being done is you're dividing by -5. To undo that or do the inverse operations, you have to multiply by 5 or -5, sorry. So you multiply by -5 on both sides. And remember, this is -5/1, so these can cross cancel. So you have x is equal to -125. Okay. And again, what we did here, because we multiplied on both sides, we used the multiplication property of equality. Okay, and we have, I think, one more scenario. So let's just say we have 3/4 x. This is a rational coefficient. It's equal to, let's say, 15 over, I don't know. Let's try, what would be a good one? 16. Okay, there you go, 15 over 16. Now, remember, this is almost exactly the same thing. This here has a coefficient, okay? That's the coefficient of x. 3/4 is the coefficient of x. And over here, we have -8 as the coefficient of x. What we did over here was we divided by -8 because that's the coefficient. Whatever's the coefficient, that's what we divide by. However, over here is a little bit different because the coefficient now is a rational number, so 3/4. Now remember, if you were to divide by -3/4, the way we did that, what we did up there, it would look something weird like this. This is a complex fraction. We don't want to do this. What we want to do is we want to multiply by the reciprocal of 3/4, which is 4 over 3. Okay, so that's what we're going to have to do. So we're going to multiply it by 4 over 3. I'm going to do that to both sides. And if you guys recall, multiplying by the reciprocal is the same thing as dividing. So these cancel out. And so on the left-hand side, we're left with just x. And over here, we can cross cancel as well. 3 divided by 3 is 1. 15 divided by 3 is 5. 4 divided by 4 is 1. 16 divided by 4 is 4. So we're left with just 5 over 4. And it's perfectly okay to leave things as an improper fraction because, well, mixed numbers are, you'll never see mixed numbers again after 7th grade, really. So get used to improper fractions. That's my recommendation. Okay, so this is pretty much what we've done. Everything we've done up to this point, that's what you guys took a quiz on. What we want to do now is talk about this two-steppers. This is the reason why we're here today. Two-step equations. Two-step equations. I'm going to write a very simple two-step equation here. This is a just a really quick example. 2x plus 1 is equal to 15. This is a two-step equation. Why? Because it takes 2 steps for you to solve it. So there are 2 operations that's being done to x. First, you will notice that, put this in a different color, you will notice that you have 2x. That's 2 times x. That's one operation. And then you're adding by 1. So there's 2 things going on here, and you have to undo both of them. So I'm going to try to make this fairly easy for you to understand. Now, if you recall the order of operations, the order of operations tell you the order in which you're supposed to do something. Like, let's just say, for instance, you have 2 times 3 plus 5 plus, I don't know, something, plus 1. Remember that you have to do what's inside the grouping symbol first before you multiply, and then you have to multiply before you add, and then you add it. Okay, so I'm going to write down the order of operations here. So the first thing you have to do for order of operations is take care of the grouping symbols. Grouping symbols. And grouping symbols can be parentheses, it could be brackets, It can even be absolute value signs. Okay, it can be all those things. Next is exponents. So if you have a problem with grouping symbols, you have to do that first, and then the next thing you do is exponents, if it's there. Next, you do multiplication and division, and these are equivalent. You just work them from left to right. I'm just going to draw an arrow there from left to right. The same thing goes for addition and subtraction. You work these from left to right as well. Okay, so that's just a recap on the order of operations. Hopefully you guys remember that. Why is this important when we're trying to solve two-step equations? Well, because we have two different operations here, we have one multiplication, one addition, we have to figure out which one of these we want to undo first in order to get the correct answer. Now, the order of operations basically says, you do it in this order. But if you're trying to solve for an equation, you actually have to work this backwards. So I'm going to write work backwards. What does this mean? What do I mean by work it backwards? So we start at the bottom, 4. Okay, we start at the bottom with 4, which is adding and subtracting. We're going to undo anything that's being added or subtracted first. Okay, anything that's not grouped together, let me rephrase that. Anything that's not grouped together that's being added or subtracted, we do that first. Because remember, whatever is grouped together has a grouping symbol. That's actually going to be the not the last one we're going to do because we're working backwards. So we start with addition and subtraction. What's being added or subtracted? Well, this, right? We're adding 1 to 2x. So we have to take care of that first. Oops. So instead of adding 1, we subtract 1. So on the left-hand side, notice the 1's go away, and we're left with 2x is equal to 14. And again, working backwards, now we do the third one, which is multiplication division. So here we have 2x. That's 2 times x. So that's what we need to undo. If we're multiplied by 2, we then divide by 2. So now x is equal to 7. And that's our answer. And again, we can always check it. We have 2 times 7 plus 1. Does that give us 15? Well, yeah, it does, because it was 14 plus 1. So that's, geez, 15 is equal to 15. So it checks out. Okay, always, always, always check your answers. Okay, no matter what. It'll give you a peace of mind because some of you guys might be thinking, how do I know if I'm right or wrong? I did all this work and I solved it, but I don't know if I'm right. All you have to do is substitute 7 for the value of x into here. And you can see whether or not you have the right answer. These problems can get really complicated, so checking becomes really important as time goes on. Let's take a look at another one. This is another example. Let's make this as example 1 now. Let's do black ink because it's awesome. Anyway, so we have 2x plus 3 is equal to 9. Now at this point in time, if you want to try this by yourselves, I suggest that you pause the video and then work it out. And then unpause it when you're done so you can see the problem worked out. Okay, wait for a little bit for you to pause it. Okay, that's good enough. So now what we're going to do is we're going to do the exact same thing. We are going to work the order of operations but backwards. So we're going to start with addition and subtraction. What's being added subtracted? Oh, we have that plus 3 there. So we need to undo that by subtracting 3 on both sides. So now, oops, we have 2x. This goes away. Is equal to 6. Now, multiplication division, right? This thing. So what's being multiplied or divided? Over here, we have 2x. That's 2 times x. So we need to undo that. Undo the multiplying by 2 by dividing by 2. We do that to both sides. So x is equal to 3. And of course, check. Check yourself. So we'll have 2 times 3 plus 3. Does that give us 9? Oh, yes, it does. That's sweet. Okay. There's a lot of different things that go along with this. Let's do another one. Example 2. Let's try. Okay, let's do this. X over 10 plus 3 is equal to 2. Now this is a little bit different, but still the same principles apply. Just because there's a fraction there suddenly, you guys shouldn't really freak out. But it works the same way. So I'm going to use purple this time because why not? Again, we have the left side and right side. Now, again, we're doing the order of operations backwards. So addition to subtraction. What is being added and subtracted? All over here, right? So we have adding 3. So we subtract 3 to both sides. Now, this, I want to remind you, is a unit. It stays together, okay? It stays together. You don't do anything to it until you're ready to. So first we have to take care of the adding 3. So we subtract 3 on both sides. So we have x over 10. This goes away. And 2 plus negative 3 is negative 1. Okay. Now, remember what this is. This is x divided by 10. Not over 10, x divided by 10. What do you do to undo dividing by 10? What is the inverse operation of dividing by 10? Well, you multiply by 10. So these two cancel out, and you multiply by 10 over here. So x is equal to negative 10. That's it, 10. So let's check it before we can say, oh, this is definitely 10. So we have negative 10 divided by 10 plus 3. That should give us 2. Well, is that true? Well, yeah. Negative 1 plus 3. That's definitely 2. Okay? So it checks out. Boom. Again, I really advocate the check so that if you did something wrong, you can go back and look at your structure. The structure is really, really important. That's why I'm really stressing, get the right structure. Know that you're supposed to do the same thing to the left side and the right side whenever you work something out. Because if you have the structure and you know that, and if you find that you check your answer and it's wrong, you can go back to look at the structure to see what's off. And it's fairly easy to identify something being off just by looking at the structure. Maybe you added something or subtracted something only on one side and not the other side. You will see that because of the structure, the way it looks, just the way it physically looks. It will show you. It will show you. Okay, so let's do another one. So you have negative 2 plus 2/3 w is equal to 10. Now this is placed in a different way than this. Prior to this point, all the variables go first and then the number second, right? Even here, the variables go first and then the number second. This here has the number first and then the variable second. But it doesn't matter. It doesn't matter because like I was saying earlier, this term is what stays together. You need to get rid of the other thing. Okay? The variable is what you're solving for. So you don't really do anything with the variable until you're ready to solve for it. Okay? So what you really need to get rid of is the minus 2. And a problem that's very similar to this is one of our original ones over here. See this number 2? You have negative 3 plus x is equal to 10. It's very simple. If you turn this into something with a rational coefficient, it will basically be exactly this. See? We have negative 3 plus x is equal to 10. Negative 2 plus a rational coefficient with w is equal to 10. So we work it out the same way. We're going to get rid of that get rid of that -2 by adding 2 to both sides. Make sure you do it to both sides. So that goes away. So we have 2/3 W is equal to 12. And now we solve this the way we have been solving it by multiplying by the reciprocal. 3/2. If it helps you out, you can turn this to 12/1 to see the cross cancel. And these cross cancel. So W is equal to 18. Does it check out? We can check this as well. So we have -2 plus 2/3 times 18 is equal to 10. Is that true? Well, order of operations, when we're working things out, says that we have to multiply first. So this becomes 1, this becomes 6. So we have -2 plus 2 times 6 gives us 12 is equal to 10. What's -2 plus 12? 10. Checks out. Okay. So this is your introduction to a two-step equation. Let's do one word problem, and hopefully you guys understand this enough at this point. You can watch this as many times as you want. You can hear me drone on and on and on and not get bored. Actually, you probably will be bored out of your brain. But hopefully you get this is useful to you. I'm gonna do a word problem. Here you go. This is from the guide to practice here. Okay, so the first thing we need to do is write an equation for this. Now, I want you guys to understand something here. Whenever you see 4x, what this means is 4 times x, right? So 4 is multiplying a number you don't know. Do you know what the 4 usually is? It's usually a rate of some kind. Usually. So if it says, okay, you have, x is equal to, I don't know, the number of candy bars. Candy. I'll just say candy. Oh, that's candy bars, I guess. X is the number of candy bars, right? What does the 4 represent? In this case, what the 4 represent is how much each candy bar costs. $4 each. Always look for a rate, because a rate, if a rate's there, then you can have something with a variable, a coefficient and a variable. Okay, keep that in mind. Okay, let's go back to this example 4 and number 4. Look at that. Eureka? How do you pronounce that? Anyway, Eureka wants to buy some CDs that cost that each cost $14. Hey, look at that, each. That's going to be a rate. So it's going to be $14 times a variable. Let's say this is CD, right? So let's say a C for CD. There you go. We have a rate. And a DVD that cost $23. Just one DVD, right? So it's 14C for $14 for however many CDs she buys, plus a DVD costs $23. So that's what she wants to buy is another DVD. So that's 23. She said exactly how many DVDs she's going to buy. Just one, a DVD, right? She has $65. Right? And solve an equation to find how many CDs she can buy. There you go. $14 times the number of CDs that she can buy plus the DVD she's going to buy. And that should give you $65. And this is how this works. If you have $65, you can figure out roughly how many CDs you can buy with using this formula. So let's work this out. Because this is the equation. There's a left side and right side. I'm doing the order of operations backwards. So we're going to subtract 23 first. Oops, 23 first. So we'll have 14c is equal to 42. Divide this by 14 on both sides. So c is equal to 3. So she could buy 3 CDs. Okay, so that's how this works. Okay, does it make sense? Now, again, we can always check. So 14 times 3 plus 23, does that give us 65? Well, this is 2 and 4 plus 23, 65, and this is 5, 6. Yeah, it checks out. So this works. Okay, so here's your homework assignment. I'm going to post it. Well, actually, I'm going to post it onto um, Google Classroom so you can see it. But if you don't see it, it's basically on page 473 through 475, all odds. Okay, that's your HW, your homework. Okay, hopefully this was useful. You can watch it as many times as you want. You can stop, record. You can, yeah, and that's about it. Hopefully you guys are well. Bye now.